Hey everyone, welcome back to part 2 of our lesson on centripetal acceleration and centripetal force. So in the first video, we had looked at the factors that affected your centripetal acceleration, which included your speed and your radius of the circular motion. So we did point out how mass doesn't actually affect your centripetal acceleration, but when it comes down to force, mass does have an effect. And so we can really see that from the formula that we get from Newton's second law. We know that from Newton's second law that the net force is the product of the mass and the net acceleration, which we were given the following formula. We had force is equal to your mass times your acceleration. And so your centripetal force is actually going to work off of this formula, but the difference here is that instead of having a more of a linear acceleration, now we're working with that circular type of acceleration, or the centripetal acceleration. So to find our centripetal force, which we can let be F of C, so that's equal to your mass times that centripetal acceleration. And then we can go one step further and replace our centripetal acceleration for the equation that we learned in the first video. So your centripetal force is equal to your mass, and then it was your speed, or velocity squared, divided by the radius. And so just like with our centripetal acceleration, we do need to have some specific units that we're working with in these questions. So your mass must be in kilograms. Your rotational speed must be in meters per second. And the radius must be in meters. So make sure you guys are working with all of those similar units. And just remember with force is that our units are a Newton, which is a kilogram times meters per second squared. So you want to make sure that you're working with all the same units. So you may need to do some conversions, just kind of like what we saw in the last video. So going back to what factors actually affect your centripetal force, so we can see that mass and speed here will affect your centripetal force. And specifically these two here, because they're in the numerator of your fraction, that means that if you increase either of these two values, then you're going to increase your force. So then on the other hand, your radius, because it's in the bottom here, or in the denominator of your fraction, if you increase that, you're going to decrease that force. So we really can tell how different factors are going to affect say the force, or your centripetal acceleration, based on where they are within a fraction. All right, so let's look at an example working with that centripetal force equation. So determine the magnitude of the centripetal force exerted by the rim of a dragster's wheel on a 45.0 kilogram tire. The tire has a 0.480 meter radius and is rotating at a speed of 30.0 meters per second. So what we're going to do here first is, so we are looking for our centripetal force. And what I'm going to do first is I'm going to actually write down all the information that I have. So here I know that I have a 45.0 kilogram tire. So that tells us the mass. And then always just double checking our units here in kilograms, so that's fine. So the tire has a radius of 0.480 meters. Our units here are in meters, so that's fine as well. And rotating at a speed of 30.0 meters per second. So that rotational speed is 30.0 meters per second. And once again, our units here are just fine. So we're looking for a centripetal force, so we can start off by writing out our equation. So that centripetal force is equal to your mass times your speed squared divided by your radius. And here we're actually given all of our different variables, so we don't have any multiple step question. This is just a very nice plug in your equation and run with it. So your force is equal to, so we're going to plug our information here. So our mass was 45.0, the speed was 30.0, and that value is squared, and divide that by your radius, which is 0.480. You can plug this all into your calculator at once. Just be a little bit careful with this squared. Make sure that it only applies to this 30 value. So if you plug all this into your calculator at once, you should get a value of 84,375. And so before we're done that one, we do need to make sure we account for sig figs and include our units. So here our mass here has 3 sig figs. Our speed here has 3 sig figs. And that radius has 3 sig figs. Meaning our answer, really nice, just has 3 sig figs. So our centripetal force there is 84,400. And this one here is a fairly big value, so we should actually put this into scientific notation. So that should be 8.44 times 10 to the power of, we've been moving our decimal 1, 2, 3, 4 times, so our exponent is to the power of 4. And then our units for force, as I had mentioned earlier, could either be newtons or kilograms times meters per second squared. So there we could just write it as newtons. So our last step is just to make sure we write this as a sentence. So we could say that the centripetal force exerted on the rim is 8.44 times 10 to the 4 newtons. I just need to scroll down here just a little bit just to finish off my sentence. All right. So make sure you guys get that sentence down. And so the rest of this lesson is the on your own practice. So make sure you guys take some time to do some of those questions. I have step-by-step solutions on my website, or there should be some answers at the bottom of the page so you can check out how you are doing. So if you guys have any other further questions, make sure don't hesitate to message me on Remind, and I will do my best to either message it out or we can have a quick Zoom chat. But thank you guys so much for watching, and good luck on your own.